This is time for STEM lesson number 2. STEM lesson number 2 is on robotics, and the second STEM will be next Saturday, April 27th. I have a little thing on the last poster, but let's look at the history of robots. The definition of robot has been confusing from the very beginning. We first see the word, and it appeared in 1921 in, I guess it's Carol Capek's play, Rossum's Universal Robots. And so that comes from the Czech word for forced labor. So that's where the word robot comes from. And then in the 1960s, about 40 years later, we have SRI International in Silicon Valley, and they developed a robot called Shaky. And that was the first robot that could truly move. It was mobile, and it could perceive things around it and make assessments. But by the mid-1980s, Honda, they started a humanoid robots that look like humans and act like humans. And they have a robot called the P3, it can walk and wave. And then the one that's called Asimo, it's very famed, and it walks, it talks, it makes facial expressions, it does all kind of different things. It looks very, very human-like. So what is robotics? And so here we're going to look at, when we look at STEM, we talk about science, technology, engineering, and math. And so robots have an intersection between the science, the engineering, and the technology part of STEM. And they produce these machines called robots, and they replicate, which means you see something and then mimic it, right? Or they substitute for human actions. They perform basic and repetitive tasks with greater efficiency than humans do and greater accuracy. That's why they're ideal for industries like manufacturing, like assembly line, moving products, and doing things like that. The introduction of AI, which stands for artificial intelligence, which is super popular right now, in robotics has given those robots the ability to handle more complex situations in all of the various industries where they work. And so what is an actual robot? And robots are programmable machines, and they can complete different kinds of tasks. And what it says here, each robot has a different level of autonomy. Auto means self, so they can operate by themselves. They don't need someone, like if you were a puppet and you needed someone else to move. Robots are autonomous. Robotic aspects, there are different aspects of robots. The first one is the mechanical construction, and it helps a robot complete tasks in the environment for which it's designed. So if you had one that was on the assembly line versus this robot, the Mars 2020 rover, it's a robot that examines the surface of Mars and it takes pictures, but it's designed to grip the surface and all of the rocks that are there because it's a very rocky terrain on Mars. So that's the mechanical construction. We build them suited to whatever function it is that they're going to perform. And then we have to have the electrical components. That's what helps to power the machine. If we don't have any power to it, it doesn't move, it doesn't work. And so usually we have an electric current that's generated through a battery, and that's what powers our robot. Then the last part of the three parts is the software. That's where we come into the programmable part. Robots contain at least some level of computer programming, and that allows them the ability to know when and how to carry out a task. So we have to have the mechanical, the actual build, then the electrical, which keeps it moving, and then the software that programs it to do what it's supposed to do. And so what are the main components of a robot? It has a control system, and we have computation. It includes all of the components that make up the robot's CPU, or central processing unit. It's programmed to tell the robot how to utilize its specific components. Maybe it's hand, maybe it's feet, maybe it's camera, all of those different components. It's similar to how the human brain sends signals throughout the body. To move your hand, to move your leg, to turn your head, all of those different things. That's sort of what the control system is, just like your brain and your body. There are different types of robots. Ones that are humanoid, that means they look like a human form, they mimic human behavior, and they perform human-like activities like running and jumping. They're designed to look like us. We have cobots, which stands for collaborative robots, and those work alongside a human. You may, if you have a human that may be picking in the fields, and then a robot would be beside them doing the same thing. Industrial robots, those are the ones I was talking about on an assembly line, and they do manufacturing. And usually they have to have at least one robotic arm that lifts heavy objects that maybe that human could not lift. There are such things as medical robots. This one is a robotic hand and it has a needle for a shot. And they will help healthcare professionals. They also have robots that help in surgery where humans can't see the tiny little parts and they would look through. You see them on commercials. And these rely on artificial intelligence and sensors to help to get through the healthcare facilities and then those very precise movements. Agriculture robots, they handle repetitive labor and those intensive tasks, and they operate things like greenhouses that need constant watering or things like that. Micro means small, so micro robotics are no bigger than a millimeter, which is very, very small. And those are used by those biotech companies, and they can help monitor and treat diseases. And then augmenting robots. These are virtual reality robots, and they can enhance current human capabilities. They replace capabilities humans have lost, like prosthetic limbs. If someone had to have their hand cut off, they could get a robotic hand, or their leg, or something like that. They would help them then in turn help that person. The next part that the robot needs to function would be the sensors. And so they bring the stimuli in, sort of like your eyes do, or your ears, or your nose, different senses. And those form electrical signals, and then the electrical signals are processed by the controller. And this is what allows the robot to interact with the human world. So a video camera, that would be the eyes of the robot. It can't see, it doesn't have a brain. So a video camera would be its eyes. It will have photoresistors that would react to light, and microphones that would be like the ears. So all of these mimic human things on the human, and they're the sensors, like your senses, your 5 senses. And they allow the robot to capture its surroundings, and then they process and they try to figure out the most logical conclusion based on all of that current stimuli. And that's what your brain does. And sometimes it does it so fast that you don't even know that it's doing that. And then it allows the controllers to relay those commands to all the other components of the robot. So it's sort of maybe like you need to move, or you need to pick something up, or something like that. And then after that we have the actuators. And those are devices that can be considered only if that robot can move or if it has a body like a human. They're responsible for the movement, and they're made up of motors that receive those signals from the control system that we just looked at. And then they're usually made of metal or elastic, and those would be operated by compressed air or oil if they're hydraulic. Then you have to have the power supply, just like we talked about before. Usually it's AC power through a wall outlet. If not, then they will have an internal battery, and they use lead acid batteries because they have a longer shelf life, and then they're safer than other batteries. Or they can use very expensive robots, use silver cadmium batteries. And then also potential power sources for the future. We don't have these yet, but we're looking into them because we want to be able to utilize things like the sun for solar robots, pneumatic power from compressed gas, nuclear power, oil, and then what's called flywheel energy, and that's generated by organic garbage. And they have what's called little bacteria that do what's called anaerobic digestion, which means that they digest those particles without using oxygen. It's a process that's typical. We do the same thing. And then we have end effectors, and that's the physical external components of the robot, and that allows them to carry out their tasks. They have tools, like robots in factories may have paint sprayers or drills on those robotic hands. The ones in surgery may have scalpels to perform cuts on people. They may have gripping claws for tasks like packing, or a lot of times they'll use robots for diffusing bombs. That way people don't get harmed in the process of trying to do that if a bomb would go off. And then how do they work? Some of them are pre-programmed to perform specific functions. We talked about the autonomous, working by themselves. Remember that we used that word at the beginning. And they carry out tasks in open environments. The sensors in them perceive the world around the robot, and then they let them to make a decision and to use those structures that we talked about, and then that gives them the best data, the best steps they can take using their effectors. And then we also have tele-operated robots, and those work in extreme geographical conditions. If you were at the North Pole or the South Pole or Antarctica and it was 100 degrees below zero, humans can't go out there, but they can send robots out there to perform specific tasks. Also underwater, we have human-controlled submarines that fix underwater pipes. If you ever drive over one of those huge bridges and wonder, how do they get under there to do something if something happens? Well, we can use robots to do that. We can also have software bots, and those are just computer programs which carry out tasks. The big thing is the chat bot. If you get online and you're asking questions, it'll come up, you're chatting with someone. A lot of times it's just a computer or just a robot, and they will simulate that conversation. Or sometimes if you get a robocall, that's why it's called a robocall, because a robot is calling you, and it might say customer service or spam or something like that. So finally, what are the applications? We can use robots in manufacturing. We talked about assembly lines. They can also weld. They can fix other machines. Healthcare, we looked at that. But not only can they give injections or use a scalpel, they can transport medical supplies throughout the hospital. And then those surgical procedures, and even some offer emotional support to patients. Companionship, children with learning disabilities, they can help them, or they can be used as a therapeutic tool for people with dementia. And then home use, like if you have one of those little Roomba vacuums that goes around and when it gets near the wall it turns, that's a robot. Also robots that mow lawns or just personal assistance to people. And then search and rescue. If people are stuck in a flood water, or they need to deliver supplies to people that they can't get to. Maybe there's a fire, maybe there's a flood, they're stranded in remote areas. They can also use them to put out fires when it's too hot for the firefighters or the conditions are too extreme for the firefighters to go into the blazing fire. So the last thing we want to look at are the pros and cons. And I listed them sort of beside each other. The pros of using robots is because we get greater precision and accuracy than a human can perform if we use a robot. They also enhance productivity, faster pace, they don't get tired, they don't need a break, they don't have to go to the bathroom, they don't have to eat, all of those things. Improve safety a lot of times since they use a computer program and a processor, they can think better and they're safer. Rapid innovation, those are equipped with many sensors and cameras to collect data, and sometimes they're more cost efficient. We have to buy the robot but not pay it an hourly rate. But then that's also some cons. People lose their job. If there's a robot out there that can do your job and then they don't need you anymore, you could lose your job. Also, they don't have any creativity. They don't use the same problem-solving skills as humans. Things like they paint pictures or sing or any of those things. A lot of times, and this is a big one, the data security risk. We have cyber attacks on robots that could expose our data or steal our data that we don't want them to steal. And then a high cost of maintaining the robots. They're expensive to repair. Sometimes they can have faulty equipment, and then if that robot shuts down, it might shut down your whole assembly line for that day until you can get it fixed. So that's a work disruption. And then also the environmental waste. We extract raw materials to build these robots, and then if we have to throw those parts away, then we get pollution and environmental waste. So there are a lot of pros, but there are also a lot of cons when we have to think about the future and using robots. If you're interested in robotics, we're going to build, and each student will get to take their robot home on the STEM 2 robotics, which is next Saturday, April the 27th. In my office from noon to 2. And if you would like to come or you're interested, you'd like to register, call me at 304-326-7762. And we would love to have anybody, and we thank you for watching our video.